Hey, thanks for tuning in to Check This Out Mathematics. And in these series of episodes, we are going to be talking about the Pythagorean theorem, Pythagorean triples, and 3 formulas that generate Pythagorean triples. And so I encourage you to like this series of episodes and subscribe to my channel and stay until the end of all the episodes where you can check out what I have behind me. So, the Pythagorean theorem, let's check that out. If we have a right triangle, then the Pythagorean theorem shows the relationship between the side lengths of the right triangle. And so let's have a right triangle here. There we go. And let's have side A and side B and side C, which is the diagonal, or the hypotenuse. Okay, so we have a right triangle. We have side A and side B and side C, which is the diagonal or the hypotenuse. And the Pythagorean theorem says that the side lengths of the right triangle are related by a squared plus b squared equals c squared. All right, so now let's show some examples of that idea. Suppose we have a right triangle and we have been given that side A is 9. So here's our right triangle. Let's move that on over a bit. There we go. Okay. And so A equals 9 and B is 12. And we're trying to find the length of side C. And so let's use the Pythagorean theorem to do that. A squared plus b squared equals c squared. And let's, since we're trying to find c, let's write it as c squared equals a squared plus b squared. And then let's substitute in the values. C squared equals 9 squared plus 12 squared. And then 9 squared is 81. And 12 squared is 144. And then we want to add those values together. So 81 and 144 gives you 225. And then to find the length of side C, that's the hypotenuse, we need to square root the 225. And the square root of 225 is 15. And so now we have found the length of side C, and we have what is called a Pythagorean triple. That's 9, 12, and 15. Pythagorean triple are three whole number lengths that solve the Pythagorean theorem. Okay, let's do another example. So this time we have a right triangle. And we want to know the length of side A this time. And so B is 24 and C is 25. Okay, and so in this given situation, we have the B length of 24 and the C length of 25. That's the hypotenuse. And we're trying to find the length of side A. And this is our Pythagorean theorem over here. And since we're trying to find A, let's put A first. So A squared would be equal to C squared minus B squared. Whenever we're trying to find something, we put it first. Good way to find something, right? Okay. And so let's substitute in our values. A squared equals 25 squared minus 24 squared for B. And then 25 squared gives us 625. And 24 squared gives us 576. All right. Now we need to subtract those. And we can see the difference of these numbers. There's a 24 that gives us to 600, and a 25 here past 600. So that's 24 and 25 is 49. So A squared equals 49. And then we need to take the square root of 49, as we did before, and that's 7. And so now we have found the length of side A as 7, and we have another Pythagorean triple, 7, 24, 25. This is a 7, 24, 25 triangle. All right, let's do one more example. This time, we have a right triangle. And A is 10, C is 26, and B is what we're looking for. Okay, so here's our right triangle, and we know that the Pythagorean theorem says that A squared plus B squared equals C squared. And now since we're trying to find B, we're going to put B first. So B squared will equal to C squared minus A squared. Okay, it's nice to solve for the variable first and then substitute in the values. So B squared equals C is 26, that's the hypotenuse, and A is 10. So we have 26 squared minus 10 squared. And then if we say B squared equals 26 squared, that's 676. And 10 squared, that's 100. And so then B squared would have to be 676 minus 100, which is 576. And as was in one of the previous examples, we know that the square root of 576 is 24. And so now we were given A and C, and we found the B value, the B length. And so now we have another Pythagorean triple. That's A is 10, and B is 24, and C is 26. Okay. So another example of finding the one of the lengths of a right triangle given the other two lengths. And this is a 10, 24, 26 right triangle. Okay, so now check this out. We're going to write down those three Pythagorean triples that we found. And let's see, we had 10, 24, 26, and we had 9, 12, and 15, and we had 7, 24, 25. 3 Pythagorean triples. And what we want to notice about these Pythagorean triples is that this last one here, 7, 24, 25, there are no common factors for 7, 24, and 25, other than 1. And so this is what we call a primitive Pythagorean triple. That's an original Pythagorean triple that has where each of the side lengths have no common factor other than the factor of 1. Right. Now the other two Pythagorean triples are not primitive. They are multiples of a primitive Pythagorean triple. Okay, so 10, 24, 26 is a multiple of a primitive Pythagorean triple, as is 9, 12, 15. It's a multiple of Pythagorean triple. And so check this out. Let's find out why that's true. So if we take 10, 24, and 26, and we show the common factors of each of those values, we would have 2 times 5 and 2 times 12 and 2 times 13. And so those are the factors of each of these values, and they share a common factor. And so that means we can reduce it by that common factor. We can divide the 2 from each one of them, and we have the 5, 12, 13 Pythagorean triple, and that is the primitive Pythagorean triple, which this multiple comes from. All right, let's check out the other one. The other one was 9, 12, and 15. 9, 12, 15. And so that's the ABC is 9, 12, 15. And we can show that 9, 12, and 15 each have a common factor of 3. And so 3 times 3 is 9, and 3 times 4 is 12, and 3 times 5 is 15. And so now we can divide out those 3's, those common factors, and simplify this Pythagorean triple to the 3, 4, 5 primitive triple. Okay. Okay, so now we know about Pythagorean, the Pythagorean theorem. We know about Pythagorean multiples of primitive Pythagorean triples. And so let's check this out. Maybe there's something going on here. Why did Mr. O'Donnell pick all those Pythagorean triples? And so let's write these down. These Pythagorean triples. Three, 4, 5. And these are all the primitive ones. And 5, 12, 13, and 7, 24, 25. And what we want to notice is that in these Pythagorean triples, the C value is 1 more than the B value. 13 is 1 more than 12. 25 is 1 more than 24. And so these Pythagorean triples have the B and C values as 1 apart. And there's a few more like this. So let's write those down. We have another one that's 9, 40, 41, and 11, 60, 61, and 13, 84, 85. Okay, and so now you can, if you like, you can test out these Pythagorean triples and be sure that they fit the Pythagorean theorem. But since we have this pattern, check out this pattern. Every C value is 1 more than the B value. And so maybe something is going on there. Maybe that can give us a formula for generating these types of Pythagorean triples, where the C value is 1 more than the B value. And so that's what we're going to do next. We're going to show our first Pythagorean generating triple formula. So this is the number 1 formula for generating Pythagorean triples. And those triples are A, B, and C, where A squared plus B squared equals C squared. And C is one more than the B value. Okay, so check this out. This is what we're going to look at in the next video. Okay, so be sure to tune in for that, and subscribe to this channel, and like these episodes, and watch all the episodes until you can check out what I have behind me. All right, very good. Thank you.